Okay, so this presentation is about the applications of 5G technology in power systems. And these are the contents of the presentation. And I have split the contents into three. After the introduction, we will be discussing about the 5G technology and then about the power systems. And after getting a clear idea about the 5G technology and the power systems, we will be discussing about the applications of 5G technology in power systems. And then there will be the conclusion and the reference. So, as an introduction to the topic, we know right now the information technology is developing day by day. And as the information technology improves, the power systems are also improving. So, if we just take a closer look, we could find out that the power industry is closely integrated to the communication industry. And the power systems are now focusing on faster transmission and incorporating wireless technologies like IoT into them. And for this purpose, power systems are hugely dependent upon the communication industry, and we could see that the 5G technology has a wide range of applications in the power systems, and we are going to discuss about those applications throughout the seminar. Now first let's take a closer look upon the 5G technology. So what is 5G technology? 5G technology means a fifth generation of mobile network. So a mobile network or a type of mobile network is usually represented by using its generation number, and each generation will be having or will be containing some kind of characteristics such as its bandwidth, data transmission speed, latency, etc. And 5G technology was developed by 3GPP. 3GPP means third generation partnership project, and 3GPP was actually formed in 1998, and they had an aim of developing 3G technology. And later they were the same ones who has developed 4G technology and also the 5G technology. And now the three main properties of 5G technology are: the first one is obviously the faster connection speed. We know 5G has a larger connection speed when compared to previous technologies. So the data transmission rate of 5G technology ranges almost from 1 GB per second to 10 GB per second. So this is kind of 100 times better when compared to 4G technology. Now the next property is low latency. Latency in communication is a delay occurred between data transmission and reception. So this delay should be minimum in order for having an efficient transmission or having an efficient communication. So we could see that the 5G has a subsequently low latency when compared to the previous technologies. The latency of 4G technology was almost about 80 to 19 milliseconds, whereas for 5G it is almost less than 5 milliseconds. And now the aim of the 5G technology or the goal of the 5G technology is ubiquitous connectivity. It means to connect everything, like every devices. Using 5G technology, we are planning or we are trying to connect all the devices. And for this purpose is achieved by the use of some kind of technologies like CHAOS, artificial intelligence, or IoT, etc. And now this figure shows the evolution of 5G technology from 1G technology. So we could see that here each of the network generations are given, and the bottom and in their bottom the respective protocols used in the each of the generations are also given. And we can see that the 1G technology was formed almost by 1980s, and it was focused on analog voice only. And when it came to 2G, the focus was shifted to digital voice, and by the implementation of 3G, the mobile data was introduced, and mobile data speed was increased, or increased mobile data speed was focused on 4G technology, which was developed almost by 2010. And when it came to 5G, the main aim of 5G is to connect everything, as we just discussed. And for this purpose, 5G is using latest technological inventions. So this is a history of 5G. So 5G doesn't has an vast history. So we could as this is because we has only even started thinking about 5G technology after the successful implementation of 4G technology. So 4G technology was implemented almost by 2010. So only after 2010 the works for 5G technology has been started. So the given in this slide are some important dates, mostly of some conferences or summits, where some important decisions about the implementation of 5G technology has been taken. So now let's look how does 5G technology works. So given below are the four main technologies which are used in 5G technology for achieving its specifications or characteristics. So first one is millimeter waves. So millimeter waves means 5G technology uses high radio frequencies for their data transmission. So one advantage of using this high frequency is that we could subsequently increase the data transmission rate by increasing the frequency. So this is why 5G has a 100 times better transmission speed when compared to 4G technology. And since its frequency is higher, the wavelength of the wave used in the 5G technology is ranging from 1 millimeter to 10 millimeter. This is why it has a name of millimeter waves. So using millimeter waves is 5G achieving its higher data transmission speed. And so second one is the MIMO. MIMO is nothing other than multiple input, multiple output. So this is just 5G technology uses MIMO antennas for data transmission, and it means it uses multiple transmitters and receivers for efficient data transmission. And third and fourth are network slicing and use of small cells. So and these two are connected. So we have just discussed that using millimeter waves we could attain a high data transmission speed in 5G technology, but it has got one big disadvantage, and this is nothing other than if you're using millimeter waves, then the data cannot be sent into long distances. One reason is that when we are trying to send data to longer distances, it may get interfered by physical objects, that it is prone to interference. So in order to resolve, or in order to overcome this problem, network slicing was introduced. And network slicing means we are slicing the coverage area or the network area into different cells, and within each of these cells a large number of antennas will be incorporated and data transmission will be occurring. So now the data doesn't have to travel a long distance, it just has to travel inside its cell only. So that's what all about network slicing and small cells. And now that we have discussed about 5G technology, let's take a look upon the power systems. So what are power systems? Power systems are those systems which contains the generation, transmission and distribution of electricity. So all these processes, these three processes are happening within the power system. And in the second point, we could see that some of the components, main components which are used in power systems for attaining these processes, which we are mentioned above. So a power plant which is used for generation of electricity, a transformer which is used for stepping up or stepping down of voltages, and a transmission line which is obviously used for transmission, substations which are also used for stepping up or stepping down of voltages, and distribution line and distribution transformer for the distribution of electricity. And one example of power system is a power grid, and power grid is using a power grid is how we get energy or power for our local use. So that's all about power systems. And now the history of power systems. So we could see that power system has a vast history unlike 5G technology, and it ranges from 1881, and given as some of the important dates which are associated with the development of power systems. And we could see that the history of power systems are only ranging from 1881 up to 1917. This is because the almost all modifications in the power system has been fully or totally achieved almost by 1917. And after 1917, what we are focusing right now, from 1917 up to today, what we are focusing on power system is to implement more applications by or implementing latest technologies into power systems. And one such example is implementing 5G technology, and that's what we are discussing right now. So this is about the history of power systems, and this is a slide which a figure which also shows the working of power systems. And we has already discussed about these components in the first slide, and we could see the generation, transmission and distribution of the electricity in a power system. So now that we has discussed about 5G technology and power systems, let's look about the applications of 5G technology in power systems. Okay, so before that, why are we using 5G technology in power system? So we could see the EPCN requirements. EPCN means Energy Power Control Network. So this is a program which was implemented targeting upon the development of power systems and other energy sectors. So EPCN has put forward some of the requirements for an efficient power system. And we could see that how 5G technology and its characteristics are highly compatible with the EPCN requirements. So if you just refer this slide, or if you just read out these left and right portion, you could see how important is to implement 5G technology into power systems. So now the first application is that it is applied to the distribution network. So what are distribution network? Distribution network is a part of power systems which distributes electric power. We have seen this distribution network in the starting of the power system slide, and they are responsible for distributing electric power for the local usage. And so we could see the main components which are present in the distribution network. Now, how does 5G is used in distribution network? So the main purpose of 5G in distribution network is the differential protection. That is 5G. Using 5G, we could implement differential protection in distribution network. And if we are using 5G technology for this purpose, we can enjoy some advantages. And these advantages are given as 3 pointers. First one is that we can access quick information about adjacent components. And these informations will be needing for implementing or needing for latest technologies or home automation like such purposes and all. And secondly, second advantage is short failure duration. Failure duration can be reduced by using 5G technology inside a distribution network, and also it will boost the reliability of the power supply. So these are the applications of 5G in distribution networks. Second application is that 5G is applied to precise load control. So load control means nothing other than controlling the loads which are connected in our households or in wherever in a power system. So precise load control is essential for faster response. And some of the requirements for precise load control are given below. And these requirements are totally achievable by the use of 5G technology. And this figure shows the application scenarios of 5G based on precise load control services. And for load control, conventionally, so we could also use optical fiber for load control. It also give almost same result, but there are some there are some of disadvantages when we are implementing optical fiber for this purpose. So we could see that optical fiber is reliable, and but the problem is that the optical fiber laying, operation, and maintenance is highly costly when compared to 5G technology. And if you're using 5G technology, it will give us a precise result, and also it could meet needs of business communication and increase the security and in a reduced cost. So this is why it is important for us to implement 5G for load control purposes. And the third application of 5G technology is it is applied to distributed power control. So we could see that the for large scale and small scale distribution energy is how it is carried out right now. And for large scale distribution energy, we could use optical cables, but it has an increased cost, and their implementation is also difficult. For small scale distributed energy sources, we could collect the basic information by wireless public networks, but we could only monitor the information using this. We cannot control the information. So now, if we are using 5G technology, it allows users to both use and generate electricity. We could apart from just using electricity, we could also generate electricity. So this is the first advantage. Secondly, the power mode of distribution network is more complex and needs unified control. So this unified control can be achievable, or it can be achieved by the use of 5G technology. So this is a figure of distributed power control using 5G technology. And the fourth application is that it is used in transmission line inspection. So we know transmission line, these are the lines which carry electric energy from one point to another. And there could be some defects associated with transmission lines while transmission. These are over limit of air distance, corrosion, wire breakage, yearly inspection. So due to these three defects, we have to do inspection year wise for ensuring the safety and the stability of the transmission line. So traditional circuit inspection method uses manual inspection method. So manual inspection is highly difficult for us to carry out, and it could also uh, give rise to high inspection cost and reduce efficiency. So if we just use 5G technology in transmission line inspection, we could directly transmit the data into a terminal, and we could access those data from that terminal. So it will conduct real-time monitoring, and it also is more reliable and strengthens the efficiency of the inspection of the line. Okay, so the next application of 5G technology is in emergency communication. So in a power system, imagine that in a power system operation, an emergency is happening or an emergency occurs. So as soon as this emergency is occurring, we have to identify this emergency situation and has to make or develop targeted solution for handling with that emergency suitably. So by using communication methods which are traditional, we cannot do a relevant information collection of an emergency situation. So we are going to need more and more efficient communication technologies for this purpose. So this is where the usage of 5G technology comes in. So various IoT sensing devices can be implemented easily using 5G technology, and they can transmit data information to a data center, and this will be a timely response unlike the conventional methods. And this data center can realize and rapid analysis, and it could make decisions to solve this emergency that we are facing. So it can also control the U4 location using UAV and other technologies. So now let's look what are some of the challenges which are faced in implementing 5G technology in power systems. First one is a 5G technical standard maturity match. So we saw that 5G design has a vast uh, history. 5G has only been started implementing from 2010, whereas power systems has been started implementing or developing since 1880s. So there is a maturity or maturity disconnection between those two 5G technology and the power systems. So we cannot just say that 5G technology is mature enough to just implement in power systems. It has got some disadvantages, and we have to do more and more researches to find efficient ways to incorporate it into the power system. So that's the first challenge. Secondly is that 5G network slicing. We has discussed about network slicing, and this network slicing could implement or could give rise to some of the security issues. And these security issues are also to be considered while implementing 5G in power systems. And thirdly, we have to make sure that the cost in implementing 5G should be maintained low when compared to optical fibers or other technologies. And at last, there are also challenges faced by signal penetration, and these challenges has to be carefully examined and researched before incorporating 5G into the power systems. So now, to conclude, 5G communication network technology, it provides a reliable guarantee for the development of smart grids. So we have seen that what are the applications which we can implement 5G in power systems. So 5G technology can be considered as a key technology which support the power network communication. But uh, along with these advantages, it has also got some challenges which we need to consider, and we has to it still needs more research and efforts according to the actual needs. So in future development process, if we just conduct proper research and find out new technologies, we could really say that 5G has a bright future in the power system development. And these are the references.